Surface Topography. So again, we have a satellite, and we have sea level, and we have ellipsoid. This is ellipsoid, and this is sea altimeter. So the signal comes here. I can get, okay, that by the signal I can determine SSH, which is this one. But I know that there is a surface which has best fit to the mean sea level, which is called geoid. Yeah, this is the geoid. Geoid has the best fit to mean sea level. But we can say that geoid can be an approximation of mean sea level. Geoid is and we know that based on temperature, pressure, salinity, topography of bottom of the sea, this sea surface does not coincide geoid. They have this small difference. So you see here, and this is called sea surface topography. So sea surface topography is the difference or height difference between sea surface and geoid. Let me rewrite it here. I can write a mathematical model for that. So sea surface topography is sea surface height minus n. N is geoid. That's all. So with with the SST, it's a good approximation actually globally. SST is less than 2 meters. So with approximation of 2 meters SST, yeah, let's say that SSH and the geoid coincide. So you can, for example, see somewhere that determining gravity field from altimetric data. Actually, they are assuming that SSH is equal to N. They will ignore this one. Or if they use oceanographic model, they can compute this SST from another source. From oceanographic models, this function of, for example, salinity, depth of water, density, temperature, different parameters are inside, and they can approximate SST. So in the case that SST is now simply geoid will be just is enough that geoid comes here, this goes SSH minus SST. So that's a geoid over ocean. So that's interesting. If we have satellite altimetry data, satellite altimetry measurements, and we correct them for those disturbing errors, we can compute SSH, sea surface height. And if we have the geoid, for example, from a global gravity model, we can determine SST. And if we have the oceanographic models, we can compute SST from them and subtract it from SSH to get the geoid. So we can play with in different form with it. And in some websites, for example, when you go and check, you see Surface Topography of, for example, Sentinel-3 mission. Yes, you can compute, but you should look and read this instruction and see if this SST that they have computed, which as probably which model, which gravity model has been used to for coming to that, because SSH come from altimetry based on the principle that I explained. But if they want to give SST from altimetry data, definitely they have used a geoid model and from the gravity model. So from where they have determined this geoid. So you should look at it. Or for example, if they have used ghost data for determining SST, therefore this SST is not computed solely from sea surface height. It's computed from, for example, sea surface height, for example, from JSON altimeter or Sentinel altimeter, and ghost data. So SST cannot be independently or solely determined from altimeter data.